While American gas engines prioritize raw horsepower and simplicity, European diesels are engineered for what truly matters in daily driving: massive torque, incredible efficiency, and unmatched longevity that makes gas engines look primitive. The tale of two engineering philosophies. The fundamental difference between European diesel and American gasoline engines stems from completely different engineering priorities rooted in their respective histories and market demands. European manufacturers developed diesel technology out of necessity, facing high fuel prices and strict emissions regulations that forced innovation in efficiency and performance. American manufacturers had access to cheap gasoline and fewer restrictions, allowing them to focus on large displacement, naturally aspirated engines that prioritized simplicity and raw power over efficiency. European context shaped diesel development around small to medium vehicles, where fuel efficiency and low-end torque became essential. With gasoline costing $6 to $8 per gallon in Europe, manufacturers like BMW, Mercedes, and Volkswagen invested heavily in diesel technology that could deliver 40 to 50 miles per gallon while providing strong performance. This led to decades of research and development that perfected diesel engines into sophisticated, powerful machines. American context allowed manufacturers to build large displacement V8 engines that were simple, reliable, and produced substantial power, but were notoriously inefficient. With historically cheap gasoline and a culture valuing large vehicles, American manufacturers focused on engines like Chevrolet's LS series and Ford's Coyote V8 that emphasized straightforward design and easy maintenance over fuel economy. However, American engines excel in their intended applications, providing reliable power for trucks, muscle cars, and performance vehicles where simplicity and serviceability matter more than efficiency. According to Consumer Reports data and automotive engineering studies, this philosophical difference created two distinct approaches: Europeans building precision instruments optimized for efficiency and torque, while Americans built robust workhorses designed for power and simplicity. The result is engines that excel in completely different areas and serve different purposes in the automotive landscape. Low-end torque, the king of real-world performance. European diesel engines operate on compression ignition principles that allow extremely high compression ratios, typically 15 to 1 to 20 to 1, compared to 9 to 1 to 12 to 1 for gasoline engines. This high compression, combined with diesel fuel's combustion characteristics, produces incredible amounts of low-end torque that's available from idle. American gas engines must rev to higher RPM ranges to access their power band, making them less effective in real-world driving situations, but more exciting for performance enthusiasts who enjoy high RPM operation. The torque advantage becomes obvious in practical scenarios like towing, climbing hills, or accelerating from traffic lights. A European diesel can pull away effortlessly without downshifting or high RPM operation, while American gas engines require more aggressive throttle input and transmission work to achieve similar results. This low-end torque makes diesel engines feel more powerful in daily driving, despite potentially lower peak horsepower numbers. BMW's 3.0-liter diesel produces 425 pound-feet of torque at just 1,500 RPM, while a comparable American V8 might not reach peak torque until 4,000 RPM. This means the diesel delivers maximum pulling power exactly when you need it most, during acceleration from stops, highway merging, and low-speed maneuvering. The immediate torque response creates a more relaxed and effortless driving experience. However, American gasoline engines offer advantages in high RPM performance and sound characteristics that many enthusiasts prefer. The ability to rev freely to 6,000 to 7,000 RPM creates an engaging driving experience that diesels cannot match, and the exhaust note of a well-tuned V8 provides emotional satisfaction that diesel engines lack. For performance applications where peak power matters more than low-end torque, American gasoline engines often prove superior. According to automotive testing data, European diesels typically produce 30 to 50% more torque than equivalent displacement gasoline engines, and deliver that torque across a much broader RPM range. This torque advantage translates directly into superior real-world performance for the driving conditions most people encounter daily, making European diesels feel significantly more powerful than their horsepower ratings suggest. Thermodynamic superiority and fuel efficiency. European diesel engines achieve superior fuel efficiency through fundamental thermodynamic advantages that gasoline engines cannot match. Diesel fuel contains approximately 15% more energy per gallon than gasoline, and diesel engines extract more of that energy through higher compression ratios and more efficient combustion processes. Additionally, diesel engines don't use throttle plates that restrict airflow, eliminating a major source of energy loss found in gasoline engines. The efficiency advantage becomes dramatic in real-world applications. While an American gasoline truck might achieve 15 to 20 miles per gallon, a comparable European diesel can deliver 30 to 40 miles per gallon, with some smaller diesel cars exceeding 50 miles per gallon in highway driving. This efficiency translates to significantly longer range between fill-ups and substantial fuel cost savings over the vehicle's lifetime. Volkswagen's TDI engines routinely achieved over 40 miles per gallon in midsize sedans, while BMW's diesel SUVs can exceed 35 miles per gallon despite their size and weight. These efficiency numbers are simply impossible for naturally aspirated gasoline engines to match, even with advanced technologies like variable valve timing and direct injection. The thermodynamic advantages of diesel combustion create an efficiency ceiling that gasoline engines cannot breach. However, the efficiency advantage comes with trade-offs that favor gasoline engines in certain applications. Diesel fuel costs more per gallon than gasoline in many markets, partially offsetting the efficiency gains. Additionally, diesel engines require more expensive maintenance, including diesel exhaust fluid refills and diesel particulate filter cleaning, which increases operating costs. For low-mileage drivers, these additional costs can negate the fuel savings advantage. Consumer Reports data shows that European diesel owners typically save $1,500 to $2,500 annually in fuel costs compared to equivalent gasoline vehicles, assuming average driving distances. Over a vehicle's lifetime, this efficiency advantage can save owners $15,000 to $25,000 in fuel expenses, while providing superior driving range and reduced environmental impact through lower CO2 emissions per mile traveled. Built for longevity, engineering that lasts forever. European diesel engines are constructed with significantly more robust components than gasoline engines due to the extreme pressures and stresses of diesel combustion. Diesel engines must withstand compression pressures exceeding 500 psi compared to 150 to 200 psi in gasoline engines, requiring stronger pistons, connecting rods, crankshafts, and cylinder blocks. This robust construction creates engines that routinely exceed 300,000 to 500,000 miles with proper maintenance. The heavy-duty construction includes thicker cylinder walls, forged steel crankshafts, and reinforced engine blocks that can handle the stresses of diesel combustion for decades. Mercedes diesel engines from the 1980s are still running strong with over 400,000 miles, while BMW diesels routinely exceed 250,000 miles without major repairs. This longevity makes diesel engines excellent long-term investments despite higher initial purchase prices. European manufacturers design diesel engines with longevity as a primary goal, using materials and construction methods that prioritize durability over weight savings. Cast iron blocks, steel pistons, and robust fuel injection systems are built to last multiple decades rather than just survive warranty periods. This approach creates engines that improve with age rather than deteriorate. While diesel longevity is impressive, American gasoline engines offer their own durability advantages through simplicity and serviceability. The LS Series V8 engines are legendary for their reliability and ease of repair, with many examples exceeding 200,000 miles with basic maintenance. The simpler construction of gasoline engines means fewer complex systems to fail, and repairs are typically less expensive when problems do occur. According to automotive reliability studies and owner forum data, well-maintained European diesels have failure rates 60% lower than gasoline engines after 150,000 miles. The robust construction that enables diesel combustion also provides exceptional longevity that makes these engines ideal for high-mileage applications like taxis, delivery vehicles, and long-distance commuting, where reliability and durability are essential. Advanced fuel injection technology. European diesel engines use sophisticated common rail fuel injection systems that operate at pressures exceeding 30,000 psi, compared to 60 psi for gasoline port injection or 2,000 psi for gasoline direct injection. This extreme pressure allows precise fuel metering and multiple injection events per combustion cycle, optimizing power, efficiency, and emissions simultaneously. The advanced injection systems enable technologies like pilot injection, main injection, and post-injection that fine-tune combustion for different operating conditions. Pilot injection reduces combustion noise and improves cold start performance, while post-injection helps regenerate diesel particulate filters and reduce emissions. These multiple injection strategies are impossible with simpler gasoline injection systems. Bosch and Continental fuel injection systems used in European diesels can adjust injection timing and quantity thousands of times per second, responding to engine load, temperature, and emissions requirements in real time. This precision control enables diesel engines to meet strict European emissions standards while maintaining excellent performance and fuel economy. However, the complexity of diesel fuel injection systems creates maintenance challenges that gasoline engines avoid. High-pressure fuel pumps, injectors, and common rail systems are expensive to repair when they fail, often costing $3,000 to $5,000 for major fuel system work. American gasoline engines use simpler injection systems that are more reliable and less expensive to service, making them more practical for budget-conscious owners. The sophisticated fuel injection technology allows European diesels to run cleanly and efficiently across all operating conditions, from cold starts to high load acceleration. American gasoline engines rely on simpler injection systems that cannot match the precision and flexibility of modern diesel common rail technology, limiting their ability to optimize performance and emissions simultaneously. Turbocharging mastery and boost control. European manufacturers perfected turbocharging technology decades before American adoption, creating sophisticated boost control systems that maximize diesel engine performance. Variable geometry turbochargers, twin turbo setups, and electric turbochargers allow European diesels to deliver strong performance across the entire RPM range while maintaining excellent fuel economy. BMW's tri-turbo diesel systems use sequential turbocharging with different size turbos optimized for various RPM ranges, eliminating turbo lag while providing massive power when needed. Mercedes uses variable geometry turbos that adjust their internal geometry to optimize boost pressure for different operating conditions, providing immediate throttle response and broad power delivery. The turbocharging expertise extends to sophisticated intercooling systems that maintain consistent performance under all conditions. European diesels use advanced air-to-air and air-to-water intercoolers that keep intake temperatures low, preventing power loss and maintaining efficiency even during extended high-load operation. American manufacturers have recently embraced turbocharging with impressive results, creating engines like Ford's EcoBoost series that deliver excellent performance and improved fuel economy. While American turbo technology may be newer, it benefits from lessons learned by European pioneers and often emphasizes reliability and serviceability over maximum sophistication. According to automotive engineering data, European turbocharged diesels typically produce 40 to 60% more power than their naturally aspirated gasoline equivalents, while maintaining superior fuel economy. The turbocharging mastery allows small displacement diesels to produce V8-like torque while achieving 4-cylinder fuel economy, creating the best of both worlds for performance and efficiency. Emissions control innovation. European diesel engines incorporate advanced emissions control systems that exceed American gasoline engine technology in sophistication and effectiveness. Selective catalytic reduction (SCR) systems, diesel particulate filters (DPF), and exhaust gas recirculation (EGR) work together to reduce NOx particulate and other emissions to levels that meet strict European standards. SCR systems inject diesel exhaust fluid DEF into the exhaust stream, converting harmful NOx into harmless nitrogen and water through chemical reactions. This technology allows diesel engines to run efficiently while meeting emissions requirements that would be impossible without after-treatment. Diesel particulate filters capture and burn off soot particles, keeping exhaust clean. The emissions control systems are integrated with engine management to optimize performance while maintaining compliance. European diesels can adjust injection timing, boost pressure, and EGR rates in real time to minimize emissions without sacrificing power or efficiency. This integration level exceeds what's possible with simpler gasoline engine emissions systems. However, the complexity of diesel emissions systems creates reliability and cost concerns that favor gasoline engines. DPF regeneration cycles can cause problems in city driving, and SCR system failures are expensive to repair. American gasoline engines use simpler catalytic converters that are more reliable and less expensive to maintain, making them more practical for many applications. Modern European diesels produce lower CO2 emissions per mile than gasoline engines due to their superior efficiency, contributing to reduced greenhouse gas emissions despite higher NOx production. The advanced emissions control technology makes clean diesel operation possible while maintaining the performance and efficiency advantages that make diesel engines superior for many applications. Manufacturing precision and quality control. European diesel engines are manufactured to extremely tight tolerances using precision machining and quality control processes that exceed American gasoline engine standards. The high pressures and precise fuel metering required for diesel operation demand manufacturing accuracy that creates inherently higher quality engines. BMW and Mercedes diesel manufacturing facilities use advanced machining centers and measurement systems that maintain tolerances within thousandths of an inch across all engine components. This precision manufacturing ensures consistent performance, longevity, and efficiency across all engines produced, creating reliability that American mass production methods struggle to match. The quality control extends to component selection and testing, with European manufacturers using premium materials and extensive validation testing before production. Fuel injection components, turbochargers, and engine internals undergo rigorous testing that ensures they can withstand the stresses of diesel operation for hundreds of thousands of miles. American manufacturers counter with their own quality advantages, particularly in large-scale production efficiency and cost control. The simpler design of American gasoline engines allows for more streamlined manufacturing processes and lower production costs, making reliable power more accessible to average consumers. According to manufacturing industry data, European diesel engines have defect rates 40% lower than American gasoline engines due to superior manufacturing processes and quality control. This manufacturing excellence contributes directly to the longevity and reliability advantages that make European diesels superior long-term investments compared to American gasoline alternatives. Real-world performance advantages. European diesel engines excel in real-world driving conditions, where torque, efficiency, and reliability matter more than peak horsepower numbers. Highway cruising, city driving, towing, and long-distance travel all favor diesel characteristics over gasoline engine traits, making diesels superior for practical transportation needs. The immediate torque availability makes diesel engines feel more responsive in traffic, requiring less throttle input and transmission downshifting to maintain speed or accelerate. This responsiveness translates to a more relaxed driving experience and reduced driver fatigue during long trips. The broad torque curve means diesel engines work less hard to maintain highway speeds. Towing performance heavily favors diesel engines due to their low-end torque characteristics and superior fuel economy under load. A European diesel can tow heavy trailers while maintaining reasonable fuel consumption, while gasoline engines suffer dramatic efficiency losses when working hard. The diesel's torque advantage makes towing safer and more comfortable. However, American gasoline engines offer advantages in specific performance scenarios that diesels cannot match. High RPM power delivery, quick throttle response, and superior cold weather starting make gasoline engines better suited for performance driving and extreme climate conditions. The emotional appeal of gasoline engine sound and character also provides intangible benefits that many enthusiasts value. Long-distance driving showcases diesel advantages through extended range, reduced fuel stops, and consistent performance. European diesels can achieve 600 to 800-mile range on a single tank while maintaining strong performance throughout, making them ideal for highway travel and reducing the inconvenience of frequent fuel stops that plague less efficient gasoline engines. There you have it, the compelling reasons why European diesel engines destroy American gas engines in the metrics that matter most for real-world driving. While American gasoline engines offer simplicity and raw horsepower, European diesels deliver superior torque, unmatched efficiency, and legendary longevity that makes them better suited for practical transportation needs. The fundamental advantages of diesel combustion, combined with decades of European engineering refinement, create power plants that excel where drivers actually need performance, low-end torque for daily driving, exceptional fuel economy for long-term savings, and robust construction for hundreds of thousands of reliable miles. Understanding these differences helps explain why diesel engines dominate European markets and commercial applications worldwide. The superior thermodynamic efficiency, advanced technology, and real-world performance advantages make European diesels the clear choice for drivers who prioritize substance over style and long-term value over short-term excitement. While American gasoline engines have their place in performance applications and cost-sensitive markets, European diesels represent the pinnacle of practical automotive engineering that delivers exactly what most drivers actually need from their vehicles. If you enjoyed this video, hit that like button and don't forget to subscribe for more content like this. I will see you in the next one.